All right, welcome back, everybody. Sorry about earlier that confusion with the horizontal shift. I finally realized the example we had earlier, which is the half, right? Absolute value of the half. So the absolute value of the half right there means when this half is between, oops, with this right here, when that half, let me go back up. When this half is between 0 and 1, if you take a 1 divided by that b, which is a half, it will give you a 2. So what that does is it actually make your x value, like I said before, it makes all the x value will have to times 2. Okay, so therefore the graph naturally will get wider because now all the x value is actually 2 times as compared to before 0, 1, 2 on the table. Remember, all everything is actually set as integer based. So now imagine all those numbers times 2. Okay, but the y value doesn't change. So in that form, then of course it gets wider. All right. So the way you look at this b is by saying, okay, if this b is a half, then it's going to be stretched. And the reason is 1 divided by the half will actually make a 2. You'll actually make the x value goes outward. Multiply everything by 2 on the x value. Therefore, it will actually become wider. So on the homework is, I think it was negative 2x. So that negative 2 right there, that 2, the negative is telling you the reflection, right? The negative part is reflection. But the 2 part, since that 2 is bigger than 1, if I kind of slowly go up, that 2 is bigger than 1. All right. So technically, all the x value will be 1 divided by 2. Therefore, it will actually be compressed. Okay. You will actually compress it horizontally. So I hope that kind of helps a little bit, help explain a little bit. All right, in this video, we're going to focus on topic number 14, operations of function. It turns out two functions, we can actually add them, subtract them, multiply, and divide them. So we're going to do a little bit of arithmetic here. Find and simplify f plus g of x. So that means I'm going to take function f plus function g, and you will actually output a different function for me. So f plus g of x simply means I'm going to take function f plus function g. So function f is 4x squared plus 6x plus 2. We'll now add on to function g, which is x plus 1. Technically, I'm supposed to put a parenthesis right here because function g is two terms representing one function. But if I put a parenthesis here, positive 1 will distribute, I will still end up with positive x and positive 1. So this parenthesis is really not necessary. So I'm going to take function f plus function g. All right, combine like terms. 4x squared got no one to combine with, so still 4x squared. 6x plus 1x is 7x. 2 plus 1 is positive 3. So this is my new function after I combine f and g together. Now, if I want to take the same two functions and subtract each other, then the parenthesis, I will actually need the parenthesis on the function g. So f minus g of x, function f minus function g. Two terms representing one function. I need to put them in the parentheses so that you know when I'm ready to combine them, I actually need to distribute my negative 1. So 4x squared stays the same, plus 6x plus 2 minus x minus 1. All right, so 4x squared got no one to combine with. 6x minus 1x is positive 5x. 2 minus 1 is positive 1. So that's another new function. So this new function is f minus g of x. All right, I can also do multiplication. So I'm gonna take function f. So multiplication is only one term. So both function now will need to be in the parenthesis. So my entire first function f will now multiply function g. So got to make sure I put them in the parenthesis. All right, so this is nothing but multiplication of polynomial. So we reviewed this a little bit. So here I'm just gonna multiply. My 4x squared will distribute. Then the 6x will distribute, and positive 2 will distribute. So then once I multiply them, we can combine like terms. So 4x squared times x is 4x to the third. 4x squared times positive 1 is positive 4x squared. 6x term, 6x times positive x is positive 6x squared. 6x times positive 1 is positive 6x. All right, positive 2 distribute. Positive 1 times 2x, positive 2x. Positive 2 times positive 1 is positive 2. So the highest exponent is 3, so that 4x to the third stays in the front, and it got no like term to combine. 4x squared plus 6x squared is 10x squared. 6 plus 2, 8x, and I got my last positive 2. So this is my new function. So it turns out quadratic multiplied linear give me a cubic function. Now, dividing the two polynomial function is a little bit trickier because it actually require us to simplify it a little bit. So I'm going to give a try, okay? I'm going to see if I can simplify. So I'm going to take function f divided by function g. So most of the time students say, okay, there's nothing else to do. Well, there's actually things to do. It just, we need to actually try to do it. What we want to do is be able to simplify this rational function. Because right now, once I wrote f over g, this has become rational function. So in order to simplify this rational function, then I need to factor first. So I'm gonna try to factor the top. I don't know if it's factorable or not, but I need to try it. See if I can factor into something where that can cancel out with the x plus 1. So greatest common factor is 2. I know that. So that's 2x squared plus 3x plus 1. So if I factor again, oops. For 2x squared, I will use x and 2x. For 1, I will use 1 on 1. So now right now my outer is 1, my inner is 2. I know 1 and 2 combined will give me 3 in the middle. Since the last sign is positive, the choice for the sign is plus, plus, or minus, minus. So I know both of these got to be plus in order to end up with a positive 3. So the top becomes 2 times x plus 1 times 2x plus 1 over. Denominator, there's nothing to factor other than 1. So I'm going to put x plus 1 in the parenthesis to show that I factor of 1. So it turns out x plus 1 cancels out. This canceling means something, okay? It actually means a lot of things. Because technically, if you look at the original rational function here, there's a restriction on the domain, which this x cannot be negative 1, okay? But when this x plus 1 in the factored portion on the top and bottom cancels out, you end up with 2 times 2x plus 1. So what that tells you is a couple of things. If you graph the original rational function, all you're going to see is a linear line. You're always going to see is a straight line. That's number one. All you're going to see is a straight line. But that straight line is actually not a linear function. It's actually a rational function. It just look like a straight line. Number two, your restriction on the domain tells you x cannot be negative 1, because if you set the denominator not equal to 0 and solve for it, it will tell you you do have a restriction on the domain. So this linear line that if you graph it, all you're gonna see is just a linear line. But it turns out when x is equal to negative 1, there is a hole there. on the graph that you don't see from the calculator. Okay, and the whole will only exist if the factors of the numerator and denominator cancels out. Okay, so sometimes when we draw a rational function, there is a hole in our graph. And the only way we know there's a hole in the graph is when the factors cancels out top and bottom. Okay, so just kind of let you know that ahead of time. So later on, we will actually run into it again with this. Well, and I will mention again in a different topic when we actually do talk about rational functions alone. So for right now, this function f divided by g is simplified into this. But I want to make sure that you understand this is not a linear function. Okay, this is not a linear function. This is still a rational function. It just the graph of it is a straight line because all the things being simplified in the process. So that's the reason why it's always a good idea to graph the original function when you first roll it out, not the simplified ones. The simplified function, you actually lose a lot of characteristic. Okay, this already losing a lot of characteristic. So if you graph this function instead of the original ones, you're not even gonna know you actually have a hole in your line. Okay, so just be aware of that. All right, so here I got two rational functions. I'm actually gonna add them. So I divide this thing into multiple steps. So kind of show you how to do it. This is very similar to when we review how to add two rational expressions. I just divide them up into steps. So the first thing we do is write them out. I'm gonna write f plus g of x. All right, so that will be x minus 4 function f plus function g. All right, the next step, I want to find the LCD. So in order to find the LCD, I need to factor both of them and count the repeated and the non-repeated factors. Um, 3x squared is x and 3x. 12, I can use 3 and 4. 3 and 4. 4 here, 3 here. That's 12. Oh, no, that's not going to work. Three, I gotta use 1 and 3. I know that. 12 is 1 times 12, 2 times 6, 3 times 4. So 3 cannot go with 3 because that will give me a greatest common factor. 2 and 6, 2 here, 6 here. So that's even bigger. That's 18 and 2. That's not gonna work. Will 3 and 4 work? Yeah, I don't know why. I don't know what I was writing. 3 and 4 will work. 4 here, 3 here. There you go. That's 3. That's 9. Excuse me. That's 4 and 9. 4 and 9 will give me my 5 in the middle. All right, inner is 9, outer is 4. All right, 4 and 9 give me 5 in the middle. I need a negative 5 in the middle. So my last sign tells me the choice is 1 positive, 1 negative. So I need negative 9 and positive 4. So the outer need to be positive. The inner need to be negative 9. Positive 4, negative 9. Negative 5 in the middle. All right. 4x squared, normally use 2 and 2. 9 is 3 and 3. That's 6 and 6. That's not going to give me my middle term, so that's not going to work. So let's try a different set. So if I would do 1 and 4 and 3 and 3, that will work because now I get 3 and 12. Outer is 3, inner is 12. So to come up with a -9 in the middle, I need -12 and +3. All right, repeated factor is x minus 3. So my LCD would just be x minus 3. Non-repeated factors, 3x plus 4 and 4x plus 3. All right, so now number 3, we need to rewrite the rational expression in an equivalent form with the LCD. So this goes back to our review. So I'm just gonna write one big denominator here. So looking at the factored form, remember the 3x minus 5 minus 12 is my first denominator. So when we do this part, we are basically saying my first denominator will go into the LCD so many times. And then so my numerator will increase by so many times. So instead of saying like that, we just say, okay, what does the LCD has that the first denominator do not have? The first denominator compared to LCD is missing 4x plus 3. So we take that 4x plus 3 times your numerator. Because that will tells me that the first denominator, original first denominator will go into the LCD 4x plus 3 times. All right, plus. What does LCD have that the second denominator do not have? The second denominator is missing 3x plus 4, so we take that times your numerator. So in other words, the second denominator will go into the LCD so many times. All right, do not distribute because we're going to do a next step. So once you wrote this out, then we're going to simplify numerator by distribution and combine like terms. So let's multiply this. Let's multiply this out. So oops. All right. Can y'all still see this? All right, I'm gonna do this on the side here. All right, x times x is 4x squared. X times +3, +3x. -4 times 4x is -16x. -4 times +3 is -12. All right, once I combine like terms, I'm just multiply them and then I'm gonna write them all out. Once I combine like term, that should be 4x squared minus 13x minus 12 plus, right? Plus. These two multiply together. That's 24x squared. 8 times 4 is 32x. That's 18x. And that should be positive 24. All right, combine like terms. That should be 24x squared plus 3,450x plus 24. All right, so the two multiplied together is this. All right, so since it's an addition right here, I can just continue to say plus 24x squared. So once I combine like term here, all right, x minus 3, 4x plus 3, 3x plus 4. All right, 4 plus 24 is 28x squared. -13, positive 50 combined, that should be positive 37x plus 12. All right, so this is simplified. All right, find the domain. Well, I have to kind of try this. Once we simplify the numerator, we need to see if this can be factored again. So maybe something can be canceled out down here. So I'm gonna try to do that here on the side. All right, 28. We know I can use 4 and 7. 12 using 3 and 4. Put 3 here, 4 here. 1 times 12, 2 times 6, 3 times 4. Okay. 1 times 28, 2 times 14. 3, 4 times 7. So my outer is 16. My inner is 21. And that give me 37 in the middle. Okay, so both of these signs got to be positive. So apparently 4x plus 3 and the 7 and the 4x plus 3 can be canceled out. So number 4, simplify the numerator and distribute, right? So now when you come to find the domain, you see that 4x plus 3 times 7x plus 4 over that. This can be canceled out. So this part that cancels out, that creates a hole in your graph when you actually grab this function. All right. But even though it cancels out, this is still part of the original rational function. So if you need to look, if you need, when you come to find the domain, you need to think back, okay, the original function when we first rolled it out, which is the addition part. If you actually grab this original function with their all the denominators there, you're gonna notice, okay, these two denominators still come up with the LCD, right? So go from go from number 1 to number 3. Number 3 is simply rewriting it. Once I rewrote it, it looks something like this. But I'm still not losing any characteristic yet because I'm not cancel things out. I'm not combine like term. I'm still have not, I'm just writing it out based on what the LCD is. So the original function contains these same 3 LCD. So you can look at these 3 LCD and say, I know I can set each one not equal to 0 and solve for x. So if I set each one of these and set not equal to 0 and solve for x, that will tell me one, the x cannot be 3. The other one, x cannot be negative 3/4. 3x plus 4 cannot equal to 0. That x cannot be negative 4 over 3. All right, negative 4 over 3 is actually smaller than negative 3/4. So in terms of domain coming from left to the right, if you graph this, this is a rational function that will be from negative infinity all the way to negative 4 over 3. That's where the hole occurs. You're not going to, excuse me, negative 3 over 4 is where the hole occurs. You're going to see there's a gap right here at negative 4 over 3. But there's a little bit of this, there's actually a piece of graph is actually between negative 4 over 3 all the way to negative 3 over 4. There's a 3 because there's it's actually a hole right here at negative 3 over 4. The graph can actually cover through it, but there's actually a hole there. And you only know that because by looking at the original denominator, the LCD, okay, and what you canceled out, you know there's a hole right there. And on the other side of the hole, my function continues from negative 3 over 4 all the way to infinity. Okay, so don't grab this one that we actually simplified. Go back and grab the original one when we first wrote it out. And you're actually gonna be able to see, okay, you're actually gonna be able to see the grad took a break at pos. Oh, sorry. The grad actually took a break at 3. Okay, so this part is not right because on the other side, the whole actually need to go to positive 3. And because there's another break right there. And from the other side of 3, we can keep on going to infinity. So 3 restriction on the domain. Give me broke up the entire graph into 4 pieces. It is tricky is right here where the hole is. Okay. All right. So finding so question number 1 on the homework. This is on the handwritten portion. I want you to take this function times that function. So the answer will look something like this. But when you first write it out, make sure you write it out as f times g of x is equal to x squared minus 9 times x plus 3. You write it like this, then you multiply it out. So the answer will look something like this. Okay. Number 2, I want you to write it out. These two functions add up together, just like what I showed you. Number 2, find the LCD, count the repeated factor and non-repeated factors. And then from 1 and 2, I want you to actually write the rational expression in an equivalent form with the LCD as a denominator. So it will be right here, this part. That's step number 3. Okay. What does the denominator has? What does the LCD has that my first denominator is missing? And that will help you rewrite the entire expression. All right, simplify it. Once you rule it out, distribute, simplify your numerator. And I think these two terms is not going to be able to cancel out. I don't think these two terms can be factored. Even if we factor out a 1, it still cannot cancel with the denominator. So that's where I want you to end up at. Okay. All right, so that was just real quick, talking about how we can add, subtract, multiply, and divide rational expression.